Hello all, today I will go through several CPU scheduling algorithms and highlight their key data structures and compare their performance results. So I used the provided GitHub repository to add two new scheduling algorithms. So I added highest response ratio next and multi-level feedback queue. So I'll just go over the algorithms first. So starting with first come first serve, FCFS processes jobs sequentially as they arrive, utilizing arrays for burst times and waiting times, along with variables to track the number of processes, total waiting time, and average waiting time, often using strings for input and process management. Next up is shortest job first, so that's this one right here. Shortest job first similarly uses burst and waiting time arrays, but introduces a process array and sorting mechanisms with a found flag and temp variable to prioritize and process jobs with the shortest burst times. First, aiming to reduce waiting times. Next up is priority scheduling, which extends this by including a priority array and employs sorting based on process priority, again using temporary variables and flags for swapping and matching to execute high priority jobs sooner. Round robin takes a different approach by focusing more on fairness. It uses arrays to manage arrival times, burst times, and a temporary array to track the remaining execution time for each process. Key variables in round robin include a total time counter, wait time, accumulator, and time quantum, which defines the fixed duration each process gets to run before the CPU is given to the next process in the ready queue. This cyclical execution ensures that no single process monopolizes the CPU and provides more equitable distribution of processing time, especially in time-sharing systems. So the two that I had added are HRRN, or highest response ratio next, which uses a list called ready queue, stores the processes, and the next process is selected based on the highest response ratio, which considers both waiting time and burst time. And then the next one I added was multi-level feedback queue. The multiple queues are used and processes can move between priority levels depending on their behavior and the time quantum of each level. The key difference is that HRRN focuses on dynamically selecting the best next process based on response ratios, while multi-level feedback queue adapts priorities over time by moving processes between queues. So I will go ahead and okay, so this is sort of just the basic GUI. So I added these two buttons for the two algorithms that I added, so highest response ratio next and multi-level feedback queue. This has a dashboard that shows CPU utilization, memory usage, and will display metrics. And just as a bonus from the GitHub repository, there's the generate barcode and QR code as part of the GUI functionality. So I'll go ahead and run a basic experiment. And I'll say 5 processes. So in this case, I'll start with first come, first serve, which automatically shows me the average waiting times, the average turnabout times, response time, and shows 100% CPU utilization. I can also go to the dashboard and I can see the arrival times of the processes, and I can see they go in order, and I can see the information about that. I can do shortest job first, and I will go ahead and put in my sample data. And it will show the same kind of metrics. So this one also shows 100% CPU utilization, as well as the same data as before. So it shows me the waiting time and response times. And then I can go to the dashboard and see when the processes were able to arrive. I can see their burst times, their start times, and finish times. Next I'll do round robin, putting in the same data. shows me that information. I can go to the dashboard. It shows me the arrival times and when the processes arrived. Priority. This one also shows 100% CPU utilization. Go to the dashboard, see the order the processes arrived, and then I'll show highest response time next. And finally, multi-level feedback queue. Okay, so once I was able to collect the data from that GUI, I then went over and stored the results in the tables. The experiment results showed that shortest job first and priority scheduling were both able to achieve 100% as well as first come first serve. But they also tended to have moderately higher waiting and turnabout times compared to the round robin and multi-level feedback queues. Round robin offered the lowest waiting and turnabout times, though its CPU utilization dropped slightly due to frequent context switching. HRRN balanced efficiency and fairness, achieving good turnabout times but had slightly lower CPU utilization, and the multi-level feedback queue was able to prioritize responsiveness across multiple queues but had low wait times and turnabout times, but had the lowest CPU utilization, on average 75.86%. In this case, first come first serve was able to achieve that 100% utilization, but suffered from the highest waiting and turnabout times because it followed the order of arrival without any optimization. In summary, each of these algorithms use similar data structures, arrays, lists, and queues, and different variables and things like that, but each one had its own unique strategy, resulting in though looking at this chart, similar results, still having a very large difference in CPU utilization as well as the wait times for each process.